Good morning students, welcome back to the session. In the previous video we discussed about cyclic quadrilateral. What is a cyclic quadrilateral? Cyclic quadrilateral is a quadrilateral whose four vertices are on the circumference of the circle. And the theorem related to cyclic quadrilateral is opposite angles are supplementary in cyclic quadrilateral and exterior angle of a cyclic quadrilateral is equal to interior opposite angle. So, related to these theorems, we are going to solve few examples. As of example 1, AB is a diameter of a circle. AB is a diameter of a circle where CD is a chord. CD is a chord of the circle which is equal to radius of the circle. That is, CD is equal to CO and OD. They are the radius of the circle. Prove that angle AEB equals to 60 degree. The figure looks a little bit complicated, but the method is very simple here. See here, you need to prove that angle AEB equals to 60 degree. Using the condition AB is a diameter. AB is a diameter. You learn that angle in the semicircle is a right angle, right? So that angle ACB equals to 90 degree. This angle is 90 degree, right? So when angle ACB is 90 degree, then angle BCE also 90 degree because AC is a straight line, right? So that angle ACB equals to angle BCE which is 90 degree. I hope you understood. Then next one is, you know that, see here, chord CD, the condition is given, CD is a chord equal to the radius AC and BD. See here, chord CD is equal to radius, So CD is equal to radius. So CD equals to DO equals to CO. CO and DO are the radii of the circle, right? So that triangle COD is an equilateral triangle. Equilateral triangle, all the three sides are equal. So here in this question, chord is equal to radius. So CO and OD are the radii of the circle. So we can say that triangle COD is an equilateral triangle. Equilateral triangle, each angle is equal to 60 degree. Therefore, angle COD equals to 60 degree. So this angle is 60 degree. So this angle is nothing but angle subtended by the chord CD at the center. So angle COD equals to 60 degree, which is the angle subtended by the chord CD at the center. Then, now see here, for this CD, this is the angle subtended at the center, that is angle COD. Then what is the angle at the remaining part of the circle? The angle for this chord at the remaining part of the circle is this one, CBD. See here, COD is the angle subtended at the center and CBD is the angle subtended at the remaining part of the circle. The relation between angle subtended at the center and angle at the circumference, remaining part of the circle is what? COD equals to half the angle, this COD, see here COD is 60 degree which is equal to twice the angle subtended at the remaining part of the circle. It means that angle COD equals to twice the angle of CBD, Therefore, angle CBD equals to half of the angle of COD, that is 30 degree. So, angle CBD equals to 30 degree. right? Now, when angle CBD is 30 degree and BCE is 90 degree, because ACB is 90 angle subtended in the semicircle. So that BCE also 90 degree. Now, in triangle BCE, this angle is 30 degree, this angle is 90 degree. So, 90 plus 30 is 120, therefore, angle AEB. So, angle AEB equals to 60 degree using angle sum property. Now let us solve this one. First, what is given you have to write. AB is a diameter and CD, CO, DO are the chord. CD is equal to radius of the circle. Okay. Then construction, join OC and OD. All these dotted lines shows the construction part. Then proof. First step is CD, chord is equal to radius, that is CD equals to CO equals to OD. So, all the three sides are equal, means it is an equilateral triangle. In equilateral triangle, each angle measures 60 degree, so that COD equals to 60 degree. Okay. COD is nothing but the angle subtended at the center. Then what will be the angle at the remaining part of the circle? The angle at the remaining part of the circle is CBD, which is half of 60 degree, which is 30 degree. So that angle CBD equals to half the angle of COD, which is half into 60, 30 degree. Now, angle ACB is 90 degree, then angle BCE also 90 degree. Because AC is a straight line where angle ACB is 90, so that BCE also 90 degree. So BC equals to 180 minus angle ACB, that is 180 minus 90 degree is 90 degree. Then this angle is 90. In triangle BCE, one of the angle is 30, another one is 90. Then the third angle will be 180 minus 120, which is 60 degree. Therefore, angle CEB equals to 60 degree. Next example is, prove that the quadrilateral formed by the internal angle bisectors of any quadrilateral is cyclic. You need to prove that angle formed by the internal angle bisectors. See here, BF is the bisector of angle B and AH is the bisector of angle A, and FC is the bisector of angle C, and DH is the bisector of angle D. So these are the angle bisectors of the quadrilateral ABCD. So you need to prove that the quadrilateral formed by the internal angle bisectors of the any quadrilateral is cyclic. It means that angle E, see here, angle E plus angle G equals to 180 and angle F plus angle H equals to 180. That means you need to prove that they are cyclic. Cyclic means sum of the angles is equal to 180 degree. Now what is given here? ABCD is a quadrilateral and bisectors AH, BF, CF and DH are the bisectors of angle ABCD. To prove that angle E plus G equals to 180 and angle F plus H is equal to 180. You know that angle bisectors bisect the angle. So that in this triangle AEB, so this angle is half of angle A and this angle is half of angle B. So that angle E, this angle E equals to 180 minus half of angle A minus half of angle B, which is equal to angle E using angle sum property. And this angle is equal to here because vertically opposite angle. Similarly, angle G is equal to 180 minus half of angle D minus half of angle C using angle sum property, and this angle is vertically opposite to HGF. So, add these two angles, we get 180 degree, that is the angle formed by the internal angle bisector of the quadrilateral is cyclic. Now, what is given here? ABCD is a quadrilateral in which AH, BF, CF and DH are the internal angle bisectors of the quadrilateral, and you need to prove that these angles are cyclic, that is FEH plus FGH equals to 180 degree. Sum of the angle is 180 degree. To prove this one, first we need to find, see here, angle AEB is equal to angle FEH because they are the vertically opposite angle. Angle FEH is equal to angle AEB, vertically opposite angles. These two are the vertically opposite angles. Now take triangle AEB. In triangle AEB, angle EAB, see here, angle EAB plus angle ABE plus AEB equals to 180 degree angle sum property. So, sum of the angles, three angles of a triangle is equal to 180 degree. Now, what is angle EAB? Angle EAB is half the angle of A because AH is the bisector. So that angle EAB is equal to half the angle of A, then ABE is equal to half the angle of B, right? So that you can write it as EAB equals to half the angle of A and AB is equal to half the angle of B plus AEB equals to 180 degree. So angle AEB equals to, take these two terms to the right side. So you get angle AEB equals to 180 minus half the angle of A and minus half the angle of B. So take as equation 1. Then in this triangle DGC, similarly sum of the angles is equal to 180 degree. So that angle GDC plus angle GCD plus angle DGC equals to 180 degree angle sum property. Then what about DCG, which is half the angle of C? Then what is GDC? GDC is half the angle of D, right? So that you can write angle DGC plus DCG. DCG is half the angle of C and CDG is half of the angle of D, which equals to 180 degree. Therefore, angle DGC, so this angle is equal to 180 minus half the angle of C minus half of the angle of D. So, these two equations, on comparing these two equations, see here, AEB is equal to FEH, vertically opposite angle. Then DGC equals to FGH, vertically opposite angles, right? So now you add this equation 1 and 2. On adding 1 and 2, you'll get AEB plus DGC equals to 180 minus half angle A minus half of the angle B plus 180 minus half of the angle C minus half of the angle D. Now 180 plus 180. So 180 plus 180 is 360 degree. And here in this term take minus half as common, then you will get minus half. If you take common, what you will get here? Angle A, angle B, angle C plus angle D, right? So what is angle A plus B plus C plus D? Sum of the four angles of the quadrilateral, right? Which is always 360 degree. So minus half into 360 degree. So minus half into 360 degree is how much? 180 degree. So 360 minus 180 equals to 180 degree. It means that opposite. See here, the internal angle bisector of any quadrilateral is cyclic. It means angle FEH plus FGH equals to 180 degree. Now I am going to solve exercise 10.5. The first question is, in the given figure, in this figure is given, in the given figure, A, B, C are the points on the circle. A, B, C are the points of the circle with the center O. Such that angle BOC is 30 degree and angle AOB is 60 degree. Find angle ADC. Now see here, angle subtended at the center, that is angle AOC is equal to angle AOB plus angle BOC. So angle subtended at the center is 60 degree plus 30 degree, which is 90 degree. So angle subtended at the center is equal to 90 degree. Therefore, see here, angle subtended at the center AOC equals to 90 degree. Therefore, angle ADC equals to half the angle of the center, angle subtended at the center, that is half into 90 degree, which is 45 degree. So, angle subtended at the center, angle subtended at the center is equal to, that is angle AOC equals to angle AOB plus angle BOC, which is angle AOB is 60 degree plus 30 degree, which is 90 degree. So angle subtended at the center is 90 degree. According to the theorem, angle subtended at the center, angle subtended at the center is double of the angle at the remaining part of the circle, that is angle AOC equals to twice the angle of ADC. So remaining part is this one, ADC. So angle, this point D is on the remaining part of the circle. So the angle is ADC. So that angle AOC is 90 degree. 90 degree equals to twice the angle of ADC. Therefore, angle ADC equals to 90 degree by 2, which is 45 degree. Therefore, angle ADC equals to 45 degree. Now, second sum. Chord CD is equal to radius. See here, chord CD. See here, chord CD equals to its radius. Question number 2. Chord of a circle is equal to radius of the circle. Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. See here, chord is AB. Now chord AB equals to, see here, chord AB is given. So chord AB is equal to the radius of the circle, that is AO equals to BO. Chord AB equals to radius of the circle. So here the radii of the circle are AO and BO. So these two are the radii of the circle. Find the angle subtended by the chord at a point on the minor arc and major arc. Which one is minor arc here? ACB. So in this figure, minor arc is ACB. This is the minor arc. Which one is the major arc? Major arc. ADB is the major arc. You need to find angle formed in the minor arc as well as major arc. Here no angles given, but the condition chord AB is equal to radius. Chord AB is equal to radius. It means AB equals to AO equals to BO. All the three sides are equal. Then what type of triangle it is? It is an equilateral triangle. Therefore, each angle is equal to 60 degree. Right? So, when each angle is 60 degree, then angle subtended at the center by the chord AB, that is AOB, is 60 degree. Angle AOB equals to 60 degree. So, when angle AOB is 60 degree, then what about angle ADB? Angle ADB equals to half the angle of 60 degree, that is 30 degree. So, angle ADB equals to 30 degree. That is, angle in the major arc is 30 degree. What about angle in the minor arc? Minor arc is ACB. So, what about angle of this minor arc? So, angle of the minor arc is half the angle of reflex of AOB. Now, angle AOB is 60 degree. What about the reflex of AOB? Reflex of AOB is how much? 360 minus 60 degree. 360 minus 60 is 300. So, reflex of AOB is 300. Therefore, angle ACB is half of the angle of this reflex of AOB, that is half into 300, which is 150 degree. So, chord AB is equal to radius. So, that AOB are the radius. So, AOB is an equilateral triangle. Then angle subtended at the center will be 60 degree because it is an equilateral triangle. Then angle subtended in the major arc, that is ADB, equals to half the angle of 60 degree, which is 30 degree. Then angle ACB. Angle ACB is equal to half the angle of reflex of AOB. Reflex means, see here, 360 minus 60, that is 300. So, angle ACB is half the angle of 300, that is 150 degree. Instead of reflex angle, you can use cyclic quadrilateral property also. See, already you found that ADB is 30 degree, right? Now, A, C, B, D are these points of a cyclic quadrilateral, right? So, A, C, B, D is a cyclic quadrilateral. In cyclic quadrilateral, opposite angles are supplementary. That is, angle D plus angle C equals to 180 degree. So, in that, angle D is how much? 30 degree. We already found here. Angle ADB equals to half the angle of AOB. That is half into 60 degree, 30 degree. Then what about angle C? Angle C equals to 180 minus 30, which is 150. You can use reflex angle or the cyclic quadrilateral property also to find this angle ACB. I hope you understood this. Thank you, students.